Hi everyone, my name is Damien and I would like to show you how to use DeepSparse engine for image classification task. After watching this tutorial, you will be able to deploy a sparse image classification model that runs solely on CPU while enjoying the inference speed typical for GPUs. Alright, let's get to it. For the sake of this demo, I have prepared a cute video of a piglet bathing in mud. What I'm going to do is pass individual frames to the engine and classify each image from a temporal sequence independently. The model that I chose is a popular ResNet 50 architecture pre-trained on the ImageNet dataset. In our Sparsity repository, you can find most popular image classification models such as different variations of ResNet, MobileNet, EfficientNet, both dense as well as sparsified. In the context of this tutorial, I could potentially run the inference in the DeepSparse engine using a dense model. However, to take full advantage of the DeepSparse engine, it is recommended to deploy a sparsified model. Thus, I'm choosing to run a model which is 95% pruned. This means that we have removed 95% of the network's weights, and also quantized, so that the weights are represented as int8 data types and not floating point numbers. Next step is setting up the DeepSparse engine. It is as simple as running a pip install. So firstly, I'd set up a fresh virtual environment. Secondly, I pip install the DeepSparse engine. Once the installation has finished, we are good to go. Now I'll demonstrate how to run the image classification task using Python API. I will open my Python editor. First, I import pipeline. This is a general object that I will be using to tell the engine what to do. Then, I will be passing the name of the task to the pipeline. We're currently working with image classification. Now, I specify the inference model by passing the stub of the ResNet 50 copied from the sparse zoo. Alternatively, you can pass the path to the folder that contains the sparse model. Finally, I define the input to the pipeline. For this toy example, this will be just an image of a cute piglet. We expect the output to contain information about the predicted classes, as well as respective pseudo probabilities. Let's return the top 3 predictions. Okay, so by now I have demonstrated how easy it is to run the image classification using the engine. As an alternative to Python API, we also support setting up a remote inference server to send the inputs over HTTP and receive predictions. And obviously, we're just having fun with the picture of the piglet. But the main feature of the DeepSparse engine is the ability to run networks without any need to utilize GPUs. Take a look at the following videos. The left-hand side shows the image classification inference run using a standard dense model in Onyx Runtime engine. On the right-hand side, you see inference from a sparsified model deployed in DeepSparse engine. Notice the significant speedup without any noticeable degradation of the inference quality. Presto! This is neural magic.